There we go. You start on the beat. 2 dimensions is usually what we refer to as length and width. Now, the problem with length and width is they are arbitrary. They've been made up by people to describe something, okay? On my whiteboard behind me, which is the length? Along the bottom or up the side? Along the bottom. Why? Because it's longer. Even though when you go to a movie theater or you turn on your TV and you switch to widescreen, it stretches this way, right? That's not the width. Technically, that's the length because it's the longer side. Everybody with me? Now, the next argument becomes this. Is this the width? Is it? So when I stand up like this and you ask me how tall I am, I say I'm 5'8". That's my width? No, what is it? If I was 5'8" wide, that'd be really bad, right? Then I'd have a TV show, My 900-Pound Life, right? So is this width? No. We call this height in reality, but what do we call it in math class? Width, because it's the shorter distance. You picking up what I'm putting down? So everybody talks about how geometry is super easy, because all you got to do is follow the formulas. But it's not that easy, is it? Because even though area only has 2 dimensions, what does our world have? Good. Nobody said 27. 3 dimensions, right? Ooh, it can be anywhere. Ooh, right? So where's the height? I don't know. It's crazy. Well, it's not really. It's just math. So you've got to be aware that these are names that have been given to something, okay? And those names can change depending on how what we are working on is oriented in our universe. Everybody with me? Okay. So area is 2 dimensions. So this sheet of paper, even though this sheet of paper has 3 dimensions, doesn't it? Because it's actually a little bit thick. Once I put it down on my desk or your desk, the amount of desk that is covered only has 2 dimensions, just a length and a width, right? Because you're just covering one face of it. Everybody with me? It requires a little bit of a intellectual acceptance of things. Everybody cool? Okay. So we are going to cover today, in the 10th grade, we are going to cover surface area of 3-dimensional things, which you did in the 9th grade. But if I were to ask Mr. Keeley, who was most of your teachers, what your worst unit was, he will probably say surface area. Because for some strange reason, people have a lot of trouble with it. And I believe it's because you think it should be easy because you have formulas. And then us math guys are like, those kids, they're all cocky and think they're brilliant. So I'm going to write this question in such a way as to fool them. And then I'm going to talk about how dumb they are and how I'm brilliant. I never do that. Okay? So, we're going to fix it today. We're going to get it out of the way. And we're also going to add new layers to your surface area knowledge. Because last year, of course, you only did a couple of different kinds of shapes. Right? We're going to go a little further with that. And we're going to hopefully have enough time to apply it to real life a little bit. Let's go with this right now. We are going to start with the 2 most basic 3-dimensional shapes. Does anybody know what they are? A cube is one of the kinds of the most basic shape. Yes. Prisms. Absolutely correct. We will start with prisms. Now, prisms, first of all, Prism is a great, well, not so great, 80s band from Canada, and they spelt it with a Z, not an S. I don't know why. But prisms are indeed the easiest of the 3-dimensional shapes. And somebody already said, Sam already mentioned a cube. A cube is indeed one kind of prism. Does anybody know what a prism has to have to be considered a prism? Can anybody define it? Everybody can name a bunch of them, but what is it really? Bronwyn? Go ahead. You can't be wrong. Pardon? 8 vertices. That covers many prisms, but not all. What's a vertice or a vertex? Yes. Okay. That covers many prisms, but not all. So would anyone else like to take a crack at it? Navneet? No, there's more to it than vertices. Because indeed it could have infinite vertices, and I'll explain why in a moment. Yes, you need a base. What do I mean by base? Or what do I mean by base? I didn't say it. What do you mean by base, Elma? Yeah, okay. So Elma, in a very roundabout sort of way, has indeed explained that. Your prism has to start somewhere. Okay? So first of all, and a prism has to be three-dimensional. So what we have is a 3D, and I'm lazy, right, as you all well know, a 3D construct, which means it's built, which consists of now I'm going to say base, and I'm going to highlight the word base because it has a lot of definitions. Usually when I say he's at the base of something, what does that mean? He's at the bottom. Absolutely right, okay? But if I take this, where is the base? The bottom, right? Now where's the base? On the side. Now where's the base? On the top. Now where's the base? Over here. Understand what I mean? It is, we want the base to be the bottom. But it also means how you start. Okay? So, consists of a base shape, which is then repeated a certain number of times. All right? So let me give you an example. What shape is this? Everyone agrees, right? What happens when I take a rectangle and I repeat it over and over and over again? Well, what shape is this? Rectangle. Repeat it over and over again. What do I get? Lots of rectangles. When I stack those rectangles on top of each other, what do I have? A rectangular prism. Everybody with me? The shape repeats. Everybody can do this one, right? Now, what's weird about that shape? What shape is that? What shape is that? What do you know about those two? They're both the same, right? So they've just been stacked on top of each other. What separates them? What separates the two shapes, the base shape? Another rectangle. Everybody cool? If you have any two identical shapes that are separated by a rectangle, you have a prism. Good? So, we can draw them. Everybody say, I can't draw those, Mr. Myers. Yes, you can. Draw a square. Draw just the L of a square, and then connect them. Yay! I'll tell you guys a story about my second grade class. In second grade, there was one kid that could draw these. And we all thought he was a wizard. That's how lame it was to be alive in 1982. Now there's grade 2 kids, making their own apps. But in 1982, Chris Watkinson can draw 3D pictures. Chris Watkinson was a super douche. I hated that kid. But he could draw 3D figures, so he was super cool. That's the easiest kind, right? Cubes and rectangles. Everyone's cool with them, yeah? All right. Now, any other repeated shape counts. Okay? So what if I start with a triangle? Can I stack triangles on top of each other? Sure. Then I get like the wedge of cheese thing or a Toblerone bar. Right? That's a triangular prism. It's not a pyramid. We're going to talk about pyramids in the next boxes. Okay? Now, 2 people mentioned vertices. I think Navneet was joking, though, when she said 9 vertices, but it was still funny. I said it can have infinite vertices. What is a prism with infinite vertices? What shape has infinite vertices? A circle has an infinite vertices because there's no corners, right? So can I have a circular prism? What is it? Cylinder. Because I just stack circles on top of each other, yes? Then somebody says, those aren't 2 faces separated by a rectangle. What shape is that? What shape is that? Cylinder. What shape is that? What shape is that? Are those circles separated by a rectangle? And then they're all like, you're still wrong. Whatever. Okay, now, when I say infinite prisms, I mean just that. Can you stack octagons on top of each other? Yes. Can you stack dodecahedrons on top of each other? Yes, you can. Okay, dodecahedron, never mind. It doesn't matter. The point I'm trying to make is they are infinite, indeed, as long as the 2 faces are the same. Do they have to be regular? Do they have to be? No, of course not. You could have this shape and stack that up, and you'd still have a prism. It'd be really hard to do the surface area, but it does exist. Everybody cool? All right. So I've given myself away slightly because the next ones we got to talk about are pyramids. How do you think pyramids differ from a prism? You guys have all seen a picture of the pyramids. How do they differ from a prism? Why aren't they a prism? Sure. Yeah, they only have one base, and they go up to a point. So pyramids have only one, and I'm going to highlight that, one base shape. And, oops, not as. And the sides taper to a point. Okay? Now again, everybody, when I say pyramid, everybody says, oh yeah, Egypt. Done. Yay. Right? And then, oh, wait. No, I can't draw the Sphinx. I'm not going to bother. Okay? Everybody knows that's kind of pyramid. But there's many others. It doesn't have to go straight up to the middle. It can lean off to the side. Right? It can point downwards, like the Louvre in Paris, if you've been to and seen that. There's a glass pyramid upside down. Right? All that matters, again, keeping in our heads, base does not have to be at the bottom. Base is the shape we start from. But there is this one special kind of pyramid that I would like to mention, and that is, of course, a cone, a circular pyramid, which is, of course, if this was 1962, we would all say was the dunce cap, but they don't exist anymore. And thank goodness, because I would have lived with that thing on my head. I would have barreled. You have no idea, man. I was a pain in the ass kid. None of you would ever guess that, would you? None of you would ever guess that, would you? Yeah. That hurts, guys. I'm all about business. All right, so everyone's cool? All right, now let's go back to grade 9. Surface area is the total exposed area of a solid. What is the surface area of my mug? Don't give me a number. Describe it to me. Total exposed area. What is the surface area? Is this included? Why? Because it's exposed. Pretend this is a perfectly circular calculator. Now what's the surface area? Just the outside, nothing in there. Got it? Good. That's grade 9, out of the way. Excellent. Now in the 9th grade, most of you, I'm betting, and in previous grades, your teachers probably got you those things where you cut them out and folded them together and built the shapes, right? Picking up what I'm putting down? And what was the point of that? That was to show you that, oh, look, kid, you can take 6 rectangles and build a cube. So it made it real easy for us to say, what's the area of a rectangle? Length times width, because you learned that in grade 3. What's the area of a cube? Well, there's 6 of them, so it must be length times width times 6. And you all went, yeah. And your teacher went, brilliant, you're smart. And we all, as teachers, are like, yeah, we should have. It's a good idea to tell them how to do that. And then you were like, yeah, great, thanks. But now we're going to put away models and we are going to do everything algebraically. Okay? Let's do so. Now, the first thing I do, I did say to draw, so we'll very quickly draw a cereal box. And of course, they're called Mattios, because that's my name and it's my cereal box. And I love cereal. Now, here's the problem. If you memorize formulas or you only try to fill in formulas, you guys get locked into where L, W, H, Q, P, all the letters live, right? Do those letters matter? No. Just like the width of the board is really the height of the board, isn't it? The letters don't matter. Why do we have those letters? Why, if those letters don't matter, did so many of your teachers spend so long drilling into your heads that area equals length times width? Why did they do it? Can you guess? Because as you can see, Tiffany, yeah, that's all it is. It's to give you, because there's no way in the infinity of space to describe how many different ways a length and a width could be. So we just arbitrarily name them length and width. What is problematic is when we change the shape, because a triangle doesn't have a length and a width, does it? What's a triangle have? A base and a height. Until I turn the triangle upside down. And then everyone's like, oh, I don't know where the base is. Right? Or we turn the triangle this way. Oops. That was a badly drawn triangle. Where's the base? Right? I would put it up there. So I would say that's the base, and then that's the height. Understand? Some of you could say, well, isn't that the base and that the height? Right? We could have arguments about that forever. We wouldn't, because we're not nerds. And that's the type of thing that nerdy people argue about. Well, they used to argue about it. Now you argue for 2 seconds, then somebody gets out their phone and Googles it, and then nobody talks to each other anymore. Back in the old days, you could fight about that over a beer for like 6 hours. But now it's like, I'm just going to Google it because you're stupid. And then you find out the right answer and nobody talks to each other anymore. It bothers me. In case any of you ever come to my house, that's my Wi-Fi password. Talk to each other. So whenever people walk in the door and say, what's a Wi-Fi password? Talk to each other! And then they're like, what? No, really, that's the password. So when you type it in, you're like, because in case any of you know, I'm not a big fan of social media. So let's carry on. Do these numbers matter? Yes, because when you draw it, it matters, right? Because you're obviously not going to say that this is 8 and this is 24, are you? Right? So where would you put these numbers? Where would you put 8? what would you call the side that I'm going to write 8 on? Pardon? You'd call it the width. So you'd put it right there and say that's the width. Is everybody happy with that? That's okay, isn't it? What would you call this one? The height. And what would you make it? The 24 or the 40? 40. Okay, so that makes this what? 24. So that makes this, according to you guys, you said this is the height, right? You called this the width. Everyone agree? Which makes this have to be the length, yes? Everyone cool with that? Now think back to grade 3. That means this rectangle here that I'm about to highlight, what are its dimensions? 24 by 40. Length by width for area. What should the length be? If you think back to Mrs. Bag Crumble in grade 3, the length is always the longest side. So what should L really be? 40. Picking up what I'm putting down? The letters don't matter. Okay? Don't get trapped by formulas. When you go to your data booklet, of course, and you remember the 9th grade, because I know you all memorized these formulas in the 9th grade, you see right there is the formula, right? With LWH. Now, did you guys label yours that way? Our LW and H's aren't there, are they? This is a cereal box lying on its side. But does that matter? No, it doesn't. Oops, wrong thing. Sorry. There we go. So we got to do the surface area, and we know it is 2WH plus LW plus LH. Now, I can't stress this enough, you guys. While you're practicing this, it's best to write it out as much as you can, because great many people cannot make that show up properly on their calculator. I'm sure all of you can, but all you're going to do is put in the numbers. 2WH. Does it matter what we name W and H? No, as long as we use the numbers. 8 and 40. 8 and 40. LW plus 24 and 8 plus LH 24 and 40. Now, how many people figure they can make that show up on their calculator with the right answer all in one go? Give it a shot. I know what the right answer is. Try. It depends on your calculator, really. Some calculators, it's really easy to do, and some it's not. Oh, and by the way, I forgot to remind you, please try to leave some blank space with each of these questions, because we're going to come back and do something else with each of these as well. So that's why I'm keeping everything small. So does anyone have an answer for me? What is it? Yes, absolutely right. 2,944 what? Squared. Why is it squared? It's a three-dimensional figure. Because we're measuring area. And area only has how many dimensions? 2. Everybody with me? Because really all this is 6 rectangles, isn't it? Everybody cool? Okay. Can we go on? Everyone's okay? All right. Turn the page over. And we are going to do the hardest kind of question you can do that is only one shape. A rectangular pyramid with those dimensions and that height. So, we'll draw it. A rectangle bottom, 32, 48. Draw the triangle. Draw the triangle. Where is the height in a pyramid? Straight up down the middle, right? So I'm going to write a dotted line to the middle that is 65 tall. Is everybody cool with that? Everyone's good? Okay. Look in your data booklet. Is there a formula for a rectangular prism? There isn't, is there? There's a square prism, pyramid, but not a rectangle pyramid. So, as I said earlier, there is an infinite amount of shapes. We don't have formulas for all of them. So we got to figure this out. What shapes make up this pyramid? There's a rectangle. That's on the bottom. What else is there? There's 4 triangles. Are they all the same? No. So I've got triangle, and I've got a second triangle, correct? Now, rectangle's easy. What's the area of a rectangle? Length times width, LW, which in this case is what? 32 by 48. We're not going to get out our calculators yet because we're not sure. Or we're going to do it all at once. What's the area of a triangle? Who remembers? Base times height divided by 2, which is length times width, isn't it? Because a rectangle is 2 triangles, yeah? So it's base times height divided by 2. But isn't there 2 of them? So if I multiply that by 2, don't they cancel? So really, I have a base times height, and then I have a second base times height, don't I? What are the bases that I know? 32 and 48, correct? Do I have a height of the triangles? Talk to your neighbor and come up with an answer. Do we have the height that we need to find the area of the triangle? Yes or no? That was a bad question. Do we have the height we need to find the area of the triangle without doing more math? That's better. Do I have this value, this h, for any of the triangles? Yes or no? What is it? 65? Okay. So you're saying, Sam, if you don't mind I'm not picking on you. I'm going to zoom in. I'm going to zoom in more. Ah! There's our pyramid, yeah? This side of the pyramid is a triangle that is 32 along the bottom. Agreed? And this side of the pyramid is 48 along the bottom. Agreed? I need the area of this face of the triangle. Where does that 65 live? Dead center of the pyramid. Does it go down the wall? So do I have the height of this actual triangle? I don't, do I? Okay. It's very snaky. What do I have? When I drop that line down, that 65, what angle does it make on the ground? 90. Right? And then I get this triangle, which I'm going to make red. What kind of triangle is that? 90-degree triangle. Do I have a system or a mathematical tool that finds me the side of a 90-degree triangle? What is it? Pythagoras. Right? So how tall is this? 65. Now this is the trick. This is where everybody screws up. How long is this side? 16. Good. And that's going to get me which height, though? The 48 or the 32? That gets me the 48. That's the red one. Agreed? Now, I'm going to delete that. Now, I need this height, don't I? What angle is this? It's a right angle again. How long is this blue one? 16. Is the blue one 16? What's the blue one? 24. The blue one is 24. Everybody with me? And now, of course, we can find our two heights by doing Pythagoras. Everybody cool? Do Pythagoras. The red height is the square root of 65 squared and 16 squared, right? And the blue height is the square root of 65 squared and 24 squared to get the answers, yeah? Once I have those, where do they go? Once I have those h's, where do I get to put them? Right up here, right? Just make sure you put the right ones with the right ones. The blue one's 32, the red one's 48. Everybody cool? That's really hard, right? Like, that's really not nice of me to put in your notes. But the reason it's in your notes is because it's so hard. It's the one we've talked about, right? The rest of this today is so easy. You're following formulas. It's super easy. Don't worry. And you guys can finish that one up. So what did you get here? $67. Oops. Sorry. 67 because it's 66.94, right? And what was your blue one? 70? Okay. And these numbers go up here. 32 gets that one. And 48 gets that one. And then what do I do with all three of these numbers once I solve them? Add it up. Everybody got it? Why did I do this to you? Because I already told you there's an infinite number of shapes, isn't there? But there isn't an infinite number of formulas. What do you do when you're faced with something with no formula? What did we do here? We created it. We broke down the shapes that we had to shapes that we knew and then added it together. Everybody cool? Everybody good? Okay, so what are those answers? Take 2 seconds to fill them out. Wrong button. Dumb. 1536. 2208. 3216, and then we add it up. Feet square. Everybody good? Nothing new, right? Should I leave that there a little longer? Or are people good? I'm going to trust that people are good. Cone, dunce cap, We're going to do something new with cones. It might be new to you guys. It depends on what Mr. Keeley liked to do with pi. First of all, check your data booklet. Do we have a formula for a cone? What is it? Pi r squared, which is the circle at the bottom, right? I'm going to highlight that because that gives me the circle at the bottom. And then what? Pi r s. What does S stand for? Slant. Did you guys do some cones last year with Keeley? No? Okay. Slant. That is this part of the cone. Because a cone is two parts, right? It's a circle and then the pointy part. Now, of course, what did I just make here? A right angle triangle again, don't I? So, again, slant height often needs Pythagoras again. Don't forget Pythagoras. Bring him to every party for the next 2 units. Okay? He's your best friend. Do I have a slant height here? Read the question. I have a height of 22, right? Know the difference. Slant height is the edge. H equals the height. Damn it. Height in the middle. I have the height in the middle. So I better Pythagoras this, right? What's the height? 22 squared. What's the bottom here? 15 squared, and then I got to square root that whole answer to do Pythagoras, right? $26.6. Now I can put that in there. So what have I got? Pi 15 squared plus pi times 15 times 26.6. Now guys, last year I know you used pi with Keeley, right? What did he ask you to do? Use the pi button, right? Right? Like we don't use 3.14 anymore. We're not in, this isn't grade school. Yeah? So I'm going to go one step further. I recommend, because from here on out, you're going to mostly be using pi as that symbol, not as any kind of number. Okay? You treat pi like you would treat an x. Do you understand what I'm saying? Not an x like ex, not your old girlfriend or boyfriend. I mean a variable. Sorry, that was stupid of me to say it that way. And I'm not even joking. I wasn't setting it up that way. I meant, yeah. So this becomes 225 pi, because 15 squared is 225. And this becomes 399.4 pi. And then you can add them together to get 624.4 pi. That's what I want to see. Does everybody understand? Everyone cool with that? Because as you go further in math, pi shows up again and again and again and again and again. And there isn't an exact number for it, so we don't want you writing a number for it. Everybody okay with that? That's how I want to see you guys doing your work in this class. Is that cool? Now, if you're the type of person that can't leave it like that, then of course all you're going to do is do 624.4 times pi equals. And that's going to get you an answer. It's going to be like 1800 or whatever, right? Everybody good? Okay. So we're going to do number 4, and then you're going to be on your own with a sheet that I have for you right here. Cylinder. A cylinder is, of course, it's got a formula, 2 pi r squared plus 2 pi r h. 2 pi, what's r? Radius. Do I have a radius? What is it? 5. Because r equals diameter divided by 2, which is 10 divided by 2, which is 5. So 2 pi r squared. Why is it 2 pi r squared? Because there's 2 circles, one on the top, one on the bottom, plus 2 pi r, oops, not r, 2 pi 5 h20. Now here's something that messes kids up on tests again. I'll sometimes draw the cylinder this way. Where's the height? Where's the h? Right here, right? So how do we make this look like we're smart people in grade 12 and at university? We're going to leave pi right there. What's 5 squared? Times 2? 50. So I got 50 pi there. What's 2 times 5? 10 times 20? 200 pi there. 50 pi and 200 pi is 250 pi. Everybody cool? And that's where I want you to leave it. Understand? What if you do all that work and it's a multiple choice test and that's not there? It's a bunch of crazy numbers. What will you do? Just do 250 times pi, right? Or will you just look at the numbers and say, well, pi is about 3. 250 times 3 is 750. So whatever number is close to 750 is the one I'm going to circle. Good? Excellent. Now, I'm going to stop for a moment, or not for a moment, for the day, and I'm going to give you an assignment. Now, I'm going to give you guys a piece of advice when you do this assignment. There's a long way to do every question on it, and there's a short way to do every question on it. The short way you can do if you think before you attack the question. The long way you can do right now easily without even thinking. Okay? I'll give you a hint. This, building your formula, was the long way. Taking each piece, adding it up, and finding the area and adding it up. That's the long way. But there are many shortcuts that you can take. All right? Of which we will discuss tomorrow, because tomorrow is a short day because of collaboration. Cool? No. Because the reason we do it, Victoria, is because if we do an X block right now, nobody needs it. But in January, when you're facing a final exam, we like to do 2 X blocks in a row, in case you're in big trouble. Cool? That's why we do it. Tomorrow we're spending the whole day with this sheet that I'm about to give you and how to make it easier to do, because it's a short day. Okay? Everybody cool? Take one of these, pass it around. I'm not going to do that thing where I announce the whole way and you guys do it right. I am going to put the right numbers on YouTube tonight, but I'm not going to show you how I got to those numbers. It'll be like a textbook, right? You'll have the right answers. And then tomorrow, I'm going to give you your textbooks, and we're going to practice this a little more, but not with shapes. We're going to practice it with words. Okay? Everybody good? All right. You can work with each other. You can work on your own. Whatever works for you guys. I am going to put the right answers on here. Yes, please do. Yes, please do. Yesterday, everyone was too hot. Today, everyone's too cold. It's crazy. Yo. Yes. Oh, thanks. You guys did it right that time, too. Whoa. Yeah. Yep.